Morning, Mr. K.
Good morning. Y'all bring breakfast with me?
Yes, sir.
Okay. What you bring? Grits and tuna?
Corned beef.
Oh, all right. What we doing? What the last time what I said we would do today?
You told us about construction.
And then we could do some of the complete the mensuration for us, right? There's something
Yes, sir.
we have to finish off from here. We're gonna do that, and then we're gonna do a little bit of construction. Y'all got your geometry sets handy?
Yes, sir.
Yes, sir.
If you have it, you have it, and or if not, of those of you who don't have it, you will have to follow, because you can only do it if you practice it. Okay. So let me see one that we would have gone through. Did we do this cylinder yet? All right. Let us look at this first question here. You see my screen?
Yes, sir.
Yes, sir.
Now, I don't know if you have access to the formula sheet, but the formula sheet says that to find the volume, I'm going to write it down here. Volume is equal to pi r squared h. What is that telling you? Look at that formula and tell me something.
That's telling you to multiply 3.14 times the radius 2 times and then times the height.
All right, something else you can see from that radius.
You have to divide that in half.
No. What does this part of the formula tell you?
The area of the
what?
That's the area of a circle.
Very good. So the area of a circle. And remember I tell you about it, sometimes as this can be considered like a prism top, because you get a top and a bottom that resemble the same, right? So sometimes you'll see area of cross section. In the cylinder, the cross section is a circle, so it's the area of the circle. In a rectangular prism, the area is the cross section is a rectangle, which means it is the base, right? In a triangular prism, then the cross section will be in the shape of a triangle. If something has the cross section of a trapezium, then the base is a trapezium, okay? And so once you find it, you have to find the area of the base, and then you multiply it by the height. So far, you understand? So,
yes, sir.
so this cylinder here, they give us the diameter. So for you to do that, it is pi. You know how to put pi in your calculator. You don't have to put 3.14 unless they tell you what to do. In your calculator has the pi button. Yeah, I see the pi button on my calculator, right? So always it's a good thing. Let me see something. This new bull person is the same one who was creating havoc in the other class.
The new bowl person that was doing it, his name began with J. I'm not sure if it's the same person.
New bull, how do you say your first name? If not, I'll put you. I'll put you the class. Because, new bull, can you answer me, please?
Asia.
Asia. Oh, that one was a boy who was creating havoc. Why I asked, there was somebody in one of the class who was kicking with students, and I would have banned him from my class. So you look like you're a good student, right?
Yes, sir.
I wouldn't get any problem with you, right?
No, sir.
Okay, which school you from?
San Pedro International.
Which one?
San Pedro International.
Okay, that's a private school. All right, that's fine. So, let let me make a couple more people co-host just in case one get kicked out. Tanya, I'm making you co-host. Michaela, I'm making you co-host to look at, because I will not be looking at the participant room, right? I'm making one more. Tiara, I'm making you co-host too.
Okay.
All right. So let us go now. So anytime as I would have shown children, every time you have to do something with a formula, write down that formula so the people know that you know what you're doing. So volume equals to pi r squared h. Now I want you to put that in your calculator quickly, and let me see how you're gonna come up with the answer. I don't want to do all the work. I want you to do something. Anybody get an answer? Neely, what you get?
Column is okay.
Go ahead.
15,780.07.
All right. Yes, because that is what I see on my calculator here. I'm going to write it. Everybody, understand how you get that? You get 1,578.07 cubic inches. All those who understand how we
Mr.
get that.
K, it's
Yeah.
15780.
1,578. 1,578.07.
They told us to use 3.14 for pi.
Okay, I just pressed the button on my the pi button on my thing. So let me do it back with what they tell us, okay? So pi is 3.14 multiplied by 11.5
Yes, sir.
Yes, sir.
multiplied by 11.5 multiplied by 38 equals,
The 11.5 is squared.
yes. So you see how it's different? You got to use what they tell us, right? 1,5,780.07. All those who understand that?
I do.
Yes, sir.
Okay. Yes, yes, Miss Bethel. Or yeah, you're asking me something, Bethel? Michaela?
I was showing that I understand.
Okay. So now that would have been a 3 point. That would be 3 points up there, right? So you would get that. Now you see the tank is filled with gasoline at a cost of $4.75 per gallon. And then they tell us that 1 US gallon is equal to 231 cubic inches. And they ask you to calculate the cost of a full tank of gasoline. So take a minute to do that for me, and then you will explain to me what we did. Remember, in this class, you don't have to get it right. You can make your mistake here. So when you go in the exam, you don't make that mistake.
I got $324.48.
Explain to me what you did.
So first I divided 15,780.07 by 231 cubic inches. And
Uh-huh.
then I
And
multiplied.
what you get when you divide that?
1 second.
Go ahead. Everybody following what you say?
Yes, sir.
So
68
so 68 point what?
311.
Stop at 3-1. That is what she get there. Who understand why she get that? Why she did that division? She divided to convert this cubic inches into gallons. And so she get 68.31. This is now gallons. You understand? And if 1 gallon is 475, we multiply this by 475 to get our answer. And when you put that in your calculator, what did you get?
$324.48.
324.48. Everybody cool with that?
That would be 47. 2 behind
47.
47. Give me the number. 47 point what?
4725.
47. Because this 4 is less than 5, it stays at 47.
25.
Okay?
That's what that is. 25.
It's 0.4725.
4725.
25.
So this 2 is less than 5. So it stays at 47. Okay? Everybody good at that?
When I didn't round the first time for the 68.31 and I multiplied it by the 4.75, I got 324.41.
All right. Now,
48,
what-
actually. 48.
really, like how you put it in your calculator there, only you were correct. If you run double times, we will get a different answer than if you make one thing at the end. So when you divide, sorry, let me undo that. When you divide this by by 231, you'll get an answer, right? Don't change that, don't wrong that answer. Just put multiply by 475, and what you get, that is when you're wrong. Okay?
Okay.
So you see why we get this different answer here? Because we wronged first and then we wronged again. So once you can go from one step to the other, you just put it in your calculator and multiply. Everybody good with me then?
Yes, sir.
All right. I think I know it has one more similar to that. Let me sort for it. All right, we'll come back to the one in a minute. All right, this is one similar to that. You see, work this out quickly on your own. Similar. This is 2020, and that other one there was. Okay, I would have changed it. All right, let us do a new one. I want you guys to do this one here. Anybody work that out? Again, the volume doesn't change. V equals to pi r squared h. So 22 over 7 multiplied by 1.5 squared multiplied by 4.2. Put that in your calculator and get it.
I got 29.7.
Anybody else get something different?
I got 29.7 also.
Okay, so I'll take that is right. So what is it? 29.7
9.7 meters cubed.
meters cube. Any question on that? So now you will get that 3 points there, right? Look at B. Work out B. B is 3 points. So work it out. Let me see what you will get.
I got 4,500 centimeters.
All right.
cubed.
Bakila, what you get?
I got 300.
How you get that?
I multiply 15 and 20.
So one box only get two sides.
So I thought it was supposed to be length times length multiplied by the height.
Aliyah.
Yes, sir.
I didn't say I was talking to Makila. Don't think you get it wrong. I asked Malaya if a box only has two sides. Not Malaya, man. Makila.
No, sir.
So how you go? So you can't use 2 dimension. Let me show you by drawing. If I have that box there, right? You see, it has a square base. Is not so? So means if this base is square, if this is 15, then this could be 15. Is not so? And
Yes,
then
sir.
the height could be 20. So to find you see, if you don't understand, make a little mental sketch of it. So this is the bottom of the box. It got a square base by drawing bar, right? So 15 by 15, and you see this is the area of this cross section. If they show you about that is the base. And so 15 times 15 times 20 will give you your answer. And 4,500 is correct. So this means it will be 15 multiplied by 15 multiplied by 20, and we will get 4,500 cm cube. Right? Good. But that would be wrong.
Question. If we're working in meters, how did we go to centimeters?
All right, let me show. So this I can divide. Let me leave that answer there. If I have 15 cm and then I got 20 cm, how do I convert that into meter? Do you know? Remember the thing I tell you, King Henry died by, this is the base, in this case, it's going to be meter, by drinking chocolate milk. You with me? So this 15 is on the cm, and we need it to come on the meters. So I am going towards my left-hand side 1 time, 2 times. So I'm going to divide this by 1 and 2 zeros, right? Because I make 2 jumps to get there. So again, I will move the point 1, 2. So 15 cm is 0, 0.15 meter. So if you multiply 0.15 by 0.15, and then this one will be 0.2, see what you're going to get.
I got, hold on. I got 0.045, but I think I did something wrong.
You didn't do anything wrong.
Okay.
Mr. Hey, I have a question.
Hmm?
After I have done like the calculation using centimeters, can I just adjust the answer to
You
meters?
can if you understand what you got to do.
Okay.
Let me see what I have here. 0.15 square multiplied by 0.2. So that was cm. Okay. All right. So Alea, how would you change this? What would you do to change that into meters, cubic meters?
I would have carried the pure decimal twice.
If you carry the decimal twice, that would be wrong. Let me see.
Multiplying what you say, multiply, I get 4.5. Multiplying what you said to multiply the point from 15.15 to and the point 2, I get 4.5.
Let me see what I have in my what I would get in my calculator. 0.15 multiplied by 0.15 multiplied by 0.2 equals to, I get 0. Let me see if my calculator is the correct format. 0.0045. That sounds right?
Yeah, I guess so, because mine say 4.5 to the power of -3.
Oh, yes, so that is correct.
-0.3.
Yes, so that will be correct. Yes. Let's see. 45. Give me a second. Let me work this thing out.
I still got 45.
Huh?
I still got 45.
I get 45 too.
4, 5. 1, 2, 3. Okay, let me explain it to you. Let me explain it to you now. I'm going to explain everything right here. Now, when you multiply it, we get 4500 cm cube. Isn't that so?
Yes, sir.
Yes, sir.
All right. Look here now. When we go from cm to m, that is 10 times, it is being 10 times 10, which would be 100. To change from cm to meter, we divide by 100 here, right? You with me?
Yes, sir.
And that is only for length. But a cube is 3 dimension. So we gotta multiply that by 100 by 100. Because cubic is 3 dimensional. Right? If we multiply that, the first one we will get 1 That is what we get when we multiply these two. And then when we multiply by the next 100, we just add on 2 more 0. So really, we are going to divide this by 1 million. I don't know if you understand what I was showing you there. If it was area, we would have multiplied 100 by 100 if it was square. But because it's cube, we got to multiply it by itself 3 times. Do you understand that?
Not really.
All right, let me go again. Let me clean up this part here. You understand how we get this in cubic centimeter, right? Good. You gotta answer me, so I know that I'm not doing. So, if we are doing a length, changing cm, let us say in this case 15 cm, we want it equal to some amount of meters. We are going in that direction, so we are going to divide 15 divided by 1, and because it's 2 jobs, we put in 2, so we're going to divide by 100. So my answer would be 0.15. You understand that?
Yes, sir.
Yes, sir.
Now let us say we find the area of the base. Let us say 15 times 15. Work out that for me, tell me what I get.
225.
225. And this is cm squared. So to change this into meters, square meter now, I would have to do 100. That was for the length, and square, it means square. So you have to multiply 100 by 100, and I will get 10,000. So if I divide this by 10,000, I have to move it 1, 2, 3. I will move 1, 2, 3, 4, right? So I have to put a 0 there. So I will get 0.0225 meter cube. Remember, you're getting smaller now, you know. And likewise, so if we are going to convert it into cube now, 15 times 15, we get that. To change that into meter, it means it was 100. That's the length. Multiply by 100 when we do area. Multiply by another 100 when we do volume, because it's cube. 100. And when we multiply all of that, you understand that? So when we multiply it, we will get 1. This is what we will get. And so if we divide, now divide this by this in your calculator and see if you get 0.0045.
Yes, sir.
Yes. So you see how we do it? Either you convert here into the meter, and you get 0.0045, or when you do that, you have to divide it by 1 million, because it's a 100. That is 100 cube, because that is what we're doing. I don't know if it makes sense to you. If anybody's still in doubt. Anybody has a doubt with that?
It makes sense.
Yes, because it's cube, we got to multiply by itself 3 times. And so now that we know our answer, when we convert it into cubic meter, it is 0.0045, and this would be meter cube, right? So calculate the number of boxes that can be packed, and that makes sense. We can't get a bigger number than that, because these are smaller boxes. How many packets can we get from a full container? So now we have to divide this here, because this is meter, we're going to divide it by 0.0045. That is why you get the big 3 points here, because they want the answer in cubic meter. So see what you will get there.
6,600.
Yeah, so that is how many little boxes you will get. Right?
Yes, sir.
Everybody good with that?
Yes, sir.
Yes, sir.
Now, did I teach you guys how to find total surface area?
Yes, sir.
Did we get a chance to work out this one in the last time?
I think we did.
Yes, sir. Yes, sir.
All right. I want you guys. See if you can work this one here, and then I will know how you stand with that. Tiara, you understand what we're doing?
Yes, sir.
Trishada, you understand?
Yes, sir.
Neely, you see it? You see Taylor is right here?
I see. I just messaged in the group so they could who available could come on.
Okay. All right. The first part, write down and simplify an expression in terms of H for the volume of the tank. So what would be that volume? You can always write a volume equals to what?
Length times width divided by height.
Huh?
Length times width, multiplied by height.
Yeah, so it could be length times width times height, and then so we go substitute 15 times 22 times h, but they want it in simplified form. So what do we get when we multiply 15 by 22?
330.
330 h. That is the answer for 2 points. You understand that? Now,
Yes, sir.
I don't want you guys to panic when you see h and thing. What formula would you would use to find the volume? Put that and replace the h with the height. Good. Now it says the tank holds 20 gallons of liquid. Good. And they say 1 gallon equals to 231 cubic inches. And they want us to calculate the value of H. It's 3 points, so you got a little work to do there. So who want to explain me the steps?
First you multiply 20 by 231.
20 times 231, because 1 gallon is this, 20 gallons could be 20 times that, isn't that so?
Yes, sir. That's
So
4,620.
4,720?
620.
4,620, and this gonna be cubic inches. Who understand that?
Yes, sir.
So now,
Yes, sir.
what is the relationship between this and the tank?
That's
Question.
the volume of the tank.
That's the what?
The volume.
Right. So the volume will be 4620. So, and what is the relationship between this and this now?
They equal to each other.
Right. So we're gonna make our equation, right? 330H equals to 4620. But I don't know how to find for H. What do I do?
You divide
330.
by
You divide both
330.
sides by 330, right?
Yes, sir.
And so
H
equal
would
to
be
what?
equal to 14.
14. So our height is 14. Test it out. If you multiply 15 by 14 by 22, if you will get that answer up there. Just test it out.
Yes, sir.
Yes, sir.
So everybody good now, right? These things, you see, is that most of these are application. You have to apply what you would have learned and put them into pieces. Don't look at the whole problem, Look at piece at a time, one little piece at a time. We did that one before. Did we do this one?
I think so, yes, sir.
Yes. This is a similar one to what we just did. So work on the volume of the value of H there. Same thing that we just did. And this is a 6 point, and this came from 2000. All the questions that we are working on here came from past people. So it is giving you a wide range of experience to be able to solve these. Makila? Makila, you gone?
Pardon me?
I see if you gone.
No, sir.
For Monday night extended, I will try to do some matrices. So be there, okay?
Okay. Mr. K, you had classes this week?
Oh yes, I do miss classes. You know that.
I didn't. When I sang in, it said, posted and join me.
That which link you use?
I think that was Tuesday and Thursday.
Now, Tuesday and Thursday I had my regular classes. Nearly you were in my Tuesday class and Wednesday and Thursday class?
Yes, sir.
Yeah, I had classes there. You use the link that I gave you. The extended class, you use the link that you signed up for. Just go there and that's how you, because I don't want to change up that.
Okay, sir.
I only have Monday on that, but you can use the same link to get it into Wednesday class. That sign up link only work for me with the Monday and Wednesday class, extended classes, okay?
Yes, sir.
Good. How many of you who are in this class here right now doing the extended? Just put your hand up if you're in this class doing the extended. Try not to miss that matrix class because every single year, one matrix question come with about 6 points, 4 to 6 points. Okay? Judah, you understand matrices?
Not fully, no, sir.
Okay, well, we're going to try to do that. I know if you can get that point, that will be fine. So, what is the expression for this one? I do think pi r squared h. What do you want pi? 3.14 multiplied by 10. Multiplied by 10, is that so?
Multiplied by 5.
Right. 5 times 5 times h. When you put that in your calculator, what we get? How many h we get there?
78.5.
78.5 each. And that is how you get 3 points. If you stop here, it is always good to write your formula so you know what number to replace. Okay? Good.
Do we cubic centimeters at the end, or is that not necessary?
You will not be penalized, but you will not be penalized if you leave it out.
Okay.
But make it a habit, because if you're doing physics and chemistry, you need to put your formula, your unit at the end. But in maths, we don't really penalize you for it. Yes, Smith?
And no, that was my hand was raised when you asked who's stone extended.
Okay. All right. So we done that, right? How do we do part B?
First, we multiply
Aliyah,
one. Yes, sir.
You are a rule girl. Yes, we have to multiply the liter. We have to multiply, right? So if we multiply 0.471, we will get 471. You agree with me?
Yes, sir.
If we multiply it by 1,000, because all we do move the point 1, 2, 3 places to the right hand side, and so that is our answer. That you will get 1 point for that, but you have to show the working to get that 1 point. If on the exam, right, you go and you write this part alone and you don't show any working, you get no point. But if you put 0.471 multiplied by 1,000 equals to 471, and you stop there, you will get 1 point because you show the working. Do you understand that? So I am begging you guys, on all your papers, show your working so that you can guarantee yourself the maximum number of points. Good. So we work there. So now what do we do next? So this here is this is the volume, right? And this is the volume. So what's the equation gonna be? This equal to 471, is right?
0.5.
No, when you multiply, no, I'm talking about this one. So this here is equal to that. You with me? I'm making the equation to solve for h.
Yes, sir.
And so we divide by 78.5 on both sides. So that will give us what h is equal to.
6.
H is equal to 6. So the height in the glass would be 6 cm. Any question on that?
Student,
Go ahead.
get the link for your Thursday class, please.
Who?
The link for your Thursday's class.
Before I leave the class, remind me.
Okay.
Okay. This is a. You guys know how to calculate these, right?
Yes, sir.
All right. I want us to do this one here now. This is a swimming pool, right? And this is a 4-point question. It says the diagram represents a pool 30 meters long and 12 meters wide, set in horizontal ground. That means flat on the ground there. The shallow end is 1 meter. This is the shallow end of the pool. And the deep end is 3 meters. That is this end here. The cross section, that means this is the shaded area, right? Is a trapezium. Calculate the area of the trapezium. Who want to explain that to me? Imagine if I just flip this over, this here would be the bottom of the pool, right? If I flip this over. So remember the cross section is so this side and over on the other side would be the same thing. So what shape is this thing here? Look at this now. Let me use my color coding. This here, this is the cross section that I'm going to draw here. That there, that there. So we got to calculate the area of this blue part because that is the cross section. Who wants to talk to me? What shape they say that is?
It's a trapezium.
Okay, so what is the formula for a trapezium?
A plus B divided by 2.
Okay.
Multiplied by.
A plus B divided by 2 is the same as half A plus B, right? So I'm going to put A plus B divided by 2. I'm going to put that in bracket. And then I'm going to multiply it by the height. How do we know what is A and what is B?
They are the two parallel sides.
So what are the parallel sides there?
1 and 3.
Very, very good. So it is 1 plus 3 divided by 2. And then what is the height? What is H?
Would it be 12?
Look along the green. Look along the blue line. Is 12 anywhere along that blue line?
Would H be 30?
H will be 30. Remember, this 3 is here. So it is 3 and 1 the parallel side, right? Because this side and that side equal. But when we look at the blue, this 12 is nowhere here. So 30 will be the height. Everybody understand me? So it will be 4 divided by, so it will be 2 times 30. So the answer will be 60. 60 meters square.
I have a question.
Go right ahead.
So even though, because usually for trapeziums, they have like the height within the shape, it would just be like anything close to the shape?
All right, now remember, we are talking about this here. Imagine that I have 1 here. I have that is my 1, right? And here is my 3. 1 and 3. If I stand this up, what will be the height from here to here? Is that it 30?
Oh, I would have seen that as like a width or length.
It's not it because it can't be inside here because here could be 3 and as you go down it gets shorter and shorter. So if I stand this up like this now, that is my 1. Up there is my 30, right? Up there is my 3. So this is my height, just like that. Okay, you think you follow what I'm showing you?
Yes, I understand.
Good. Now, do you see how I draw? You can draw on your paper, you know. So everybody good with that? And now they want the volume. So remember, this here is a prism. And it's a trapezium prism. That means the base is a trapezium. So any prism is the area of the base times the height. So now we know the area of the base is 60, right? What is the height of what is the height of the pool now?
12.
It'll be 12. Because if this is the bottom of the pool, imagine you flip this and this is the bottom, then the height would be that part there. Is that so?
Yes, sir.
And that would be the volume. And this time it is meter cube. Area, meter square. Who understand that?
I do.
Now, sometimes they can ask you to convert this, ask you how much water is in the pool. And they would give you that, let's say, this is just tentative, right? They can say 1 meter cube is equal to 1,000 gallons. How much water is in the pool, right? So all you would have to do, multiply this by 1,000. Isn't that so?
Yes, sir.
Good. So I'm just putting in that because it can come. Now, some of you might want to know why we look at these things here, right? Now, this is a you know, nowadays all the most buildings, their code, you have to do a wheelchair ramp, right? And so this is one, but this came from 2004, people, a long time. Don't be surprised if one like this come back here. You see what they say? The loading ramp is to be built in the form of a right triangular prism. That means this here would be the cross section, because the prism takes the shape, the name of the prism takes the shape of its base. And since they say triangular prism, this would be the base. That means this, if you flip this to make your calculation, you have to do the base is length 17 and the width is 4. The height is 0.6 meter. Calculate the volume of concrete required. This one here, they didn't break it up for you. But so what do you know is the volume for any prism? Volume of prism.
The cross-section area times
cross-section,
height.
area of cross-section multiplied by height, right?
Yes, sir.
So our cross-section is this part here. So what is it? How do we find the area of the triangle here? It is 17 times 0.6, right?
Yes, sir.
Divided by 2, because that is what we do, and then we multiply that answer by 4, and that is how we get 3 points. You see how we applied ourselves? Remember, any prism, find the cross section first, and whatever they tell you is the cross section, because they can't draw this so that this is at the bottom. So that is why they draw it like this. Okay? Put that in your calculator and tell me what you get.
20.4.
So the amount of concrete they're gonna pour into this structure is 20.4 cubic meter. Good? And I think I give you enough content in mensuration.
I have a question. You said whenever we're trying to find a volume of a cross section, a volume of a prism, we find the cross section first.
I didn't say that. The formula say that. I just kidding you. That is correct. This is paper 2. This is not this paper 3. Let me go to paper 2. It would be in your formula sheet, baby, okay? So if you don't have to remember all those formulas like that. So you see, okay. You see here it say this is a prism. They want the volume. You see the mark here, area of cross section. Then times the length. That means times the height of it. You see? So if it's if it's a triangular prism, you use the area of a triangle. If it's a rectangle, you use the area of the rectangle times the other dimension. Okay? Everything you want about, you talk about the circle here, circumference, area. It tells you about the cylinder, volume of cylinder. All the formulas are here. You see, tell you about the area of the trapezoid here.
Yes, sir.
Good. So you don't have to worry. You got, and then when you have to do Pythagoras theorem and all them things, it's right here. Now, when you look at the Pythagoras theorem, if you have a triangle A, B, and C, you might want to know what this means. All it means, what is R, is the hypotenuse square is equal to the square of the other two sides. Right? So forget about that if you know. Once you know the you look at the longest side. This here is always equal to the sum of the other two sides. If they give you the hypotenuse and ask you for a short side, then you will have to subtract the two sides, right?
Yes, sir.
Everybody good with scientific notation and so forth. So let us jump right into that geometry now. This one here has some of it. Okay. Let us look at some of these circle theorem. Now, for you to understand circle theorem, you need to look at the video by yourself, right? Because I'm going to share this video with you guys, and you will have to go there. Let me share that screen with you so that you see what it, and then now you see here there are a number of circle theorems that you can go through individual as you go along, right? Different ones it has, but this first one here tells you about all, but it didn't go through in little details. You see, these are long videos. I don't want to show you any of those. When you get all the circle theorems in 10 minutes, this is a good one to look at. So you can do that in your own time. But I'm just going to give you a basic on this one.
Hello and welcome to Teen Topics, where you'll be taught all you need to know about circle theorems. So a circle theorem is basically finding the angle within a circle, which has another shape inside it. These shapes are generally not drawn to scale, which makes it that little bit more difficult. But don't worry, in the next few minutes you will learn all you need to know about circle theorems. Okay, starting off. A chord is a line that lies anywhere below the diameter that goes from one side to the other of the circle. In this image, the perpendicular bisector of the chord passes through the centre of the circle. Number 2. Here we have a semicircle. Say we put another one on top and put a random triangle inside this half and name these angles A, B and C, then this angle B will become 90 degrees. But this is no fluke. Even if we have this triangle instead, or maybe even this one, they will always be 90 degrees. In fact, put any triangle here and it will still add up to, yep, 90 degrees. Number 3. A tangent is a line that passes the outside edge of a circle. When this line is touched by the radius, that means the angle will be 90 degrees. Number 4. A subtended angle is almost like our eyesight. When we look at an object, our vision is focused on that. Taking this tree and this man for instance, the subtended angle is 22 degrees. The subtended angle is basically the line, arc or object opposite to the inner triangle. Number 5. Angles in the same segment subtended by the same arc are equal. For example, ABC is the same as ADC. Number 6. When you have an arrowhead shape inside a circle, the inner angle here is twice this angle at the circumference. Number 7. The diagram shows a cyclic quadrilateral, which is a four-sided shape with all of its corners touching the circumference. What is different about this is that the opposite angles both add up to 180 degrees, so A and C would add up to 180, and B and D, same thing. Number 8. Going back to the tangents, if you do not remember, go back to number 3, then the lengths of the two tangents would equal the same amount. To explain that with a visual guide, length AB is the same as AC. Number 9. The angle between the tangent and a chord is equal to the angle in the alternate segment. This is also known as an alternate segment theorem. Here was quite a confusing looking sum that you are likely to get in a maths exam. Have a look at this image and have a go. Can you do it? Pause the video and see what you can get. Okay, so the sum we would do is A equals 180 minus 70. Divide this all by 2 and this will equal 55 degrees. As some people already know, the base of isosceles triangles will always equal. Now we get the 90 at angle B and take 55, which equals 35 degrees. How was I able to get this 90 degrees? Well, as previously explained, when a radius and a tangent meet, this creates a 90 degree angle. Now we have 35 degrees from the previous answer, we times that by 2 to get 70. Now we take it away from 180 degrees. Finally, we divide that 110 by 2 to give us 55 degrees. This is the angle marked D. Congratulations if this was your answer. If there is anything you do not quite understand, give me a shout out in the comments down below and I will happily answer your question. If you found it interesting or helpful, then maybe consider pressing that free little subscribe button down below. It really helps me out a lot.
So there are 7 theorems. Most time they ask you for, let me show you back my screen. Most time, 3 theorems they will be testing you. 1, the alternate segment theorem. 2, angle in a semicircle. And then you have to make a calculation. So can you see the screen? This is 2023 paper 2. Who wants to tell me what will be the size of angle ABC? That is the letter in the middle, angle ABC. So this is the angle they're talking about. Who wants to tell me that?
90 degrees.
Why?
Because it's the angle in a semicircle.
All right. Once you see this dot and O, that means that this line here is your diameter. What? And then this arc up here is your semicircle. And this angle here is in the semicircle. So if I have the angle there, it will still be 90 degrees because angle in a semicircle is 90 degrees. So the answer for this one is 90 degrees. You get a free 1 point because you didn't have to work for that. Who understand that?
I understand.
Me too.
All right. They want angle BCE now. Think of it, angle BCE.
You add up 37 plus 90.
Angle BCE. How we get that?
Would you add up 37 and 180?
No.
And then after
BC. They want B.
And that'll be 360.
No.
I can't remember.
All right. We can do it 2 ways. We can do it 2 ways, but I'm going to show you something.
Or straight line.
90 degrees.
BCE. Remember earlier, a radius and a tangent forms a right angle, right? Good? So if we know this is 90, but you're working yourself hard, and that is 37, it would be, or we can
say 90 plus 37, take that away from 180.
Or we can just take away 37 from 90 because this is already 90. 90, right? 90 take away 37. What do you get?
50.
You get 50 here, right? Is that no? You can't get 50.
53.
53. So if this little, let me use a different color. If this little piece for the up to the triangle part, this little piece is 53, and then we know that all of this is 90. How do we find this little piece outside here?
So take that away from 90.
So 90 take away 53. What we get?
37.
37. So now look at this now.
So tell Kiki.
Now I'm going to clear this away so that you can see. Now remember, in the video it says the angle and a tangent, the angle formed between an angle and a a chord and a tangent is equal to the angle in the alternate segment. Right? Now, it is easy to do what I'm going to show you. We can either shade this segment here, and when we go straight opposite, that is the opposite segment, so that is 37. So that means this angle here will be 37. But an easy way that I show my students how to do it, let me draw it so that you can see. This here is the chord, right? This here is the tangent. Let me just write it properly. This here is the tangent. So this portion here is the angle formed between the tangent and the chord. All those understand that?
I understand.
And so to get the alternate segment, you start, let me use this. To get the alternate segment, you start on the chord. This is the chord. I follow the angle that is going to the chord. And so this is, you see, this is the angle up here that is standing on the chord, right? So that means this angle will be equal to this angle. So that is 37. And isn't that what we calculated?
Yes, sir.
So they can give you, they can either give you this and ask you to find that one, or they can give you that one and ask you to find this one. So you have to know what the alternate segment is. So this answer here is 37 degrees. Any question on that?
No, sir.
Oh, my diagram gone. Let me reset it. So we know that this one is 37. We know that this one here is 90. Now this one angle DAC. DAC.
Would it be 90 take away 30?
DAC. How we get that?
Would it be 90 take away 37?
No.
25.
How you get that?
I added 65 and 90 degrees and then subtracted one. I subtracted it from one.
Yeah, that is absolutely right. Let us refer to the theorem again. This is my radius, right? This is my tangent. Radius on a tangent is 90 degrees, right? Good. So if we look at this triangle here, that is the triangle we're talking about. So we know 90, we know 65, we got to find that. So it would be 180, take away 90, take away 65, and that will give us our answer. What do you, 25?
Yes, sir.
Everybody follow?
Yes, sir.
Butler, you understand? Trishana?
Yes, sir.
All right. Let us try another one. I do it circle theorem, so let me see if we went through this, so I'm not going to go back unless anybody wants me to do. Look at this one. This is a circle theorem. This from 2016 paper. Answer those three questions. They're simple. So go ahead and see what you will do. They want angle BCA. So they want this angle. That's one angle that they want. BCA. They want angle ABD. Angle ABD. They want this angle here. And they want angle CAD. Angle C. And they want that angle up there. So those are the three angles. What is the first one?
90 degrees.
This one here is 90 degrees. Good. All right. Let's go. How do we find angle ABD?
We take away 56 and 90 from 180.
Huh? Yes.
We take away.
And that will give us this angle here, right? Or we can do this, yes, because we look at this whole right angle triangle here, right?
Yes, sir.
Remember,
So you can't do that on straight line.
pardon me?
It's on a straight line.
Where that cannot, you can't do nothing on straight line there. So this 56 and this 90, when we add it and take away from 180, we will get this one here. What will that be? 34?
Yes, sir.
34 degrees. So what will that one down here be? This one here.
34.
34. And that will be the alternate segment, right? I don't know if the drawing too confusing. This would be the chord, right? And remember, if I draw the angle on the chord, this angle would equal to that angle at the bottom there. So 34 would be it. So you see they're testing angle in the semicircle, alternate segment, and your angle properties. Any question? All right. Do all of this, A and B. This is the last circle theorem I'm going to do because I want to do a little bit of construction today with you guys. Angle LMN. LMN. You know what the answer for that one is?
90.
90 degrees. They want MLN. MLN. That is simple.
52.
52.
That means 38 minus 90, and this is 52, right? They want
Yes, sir.
MNP. They want this one now.
52.
Because this is the chord, this is the tangent. We draw the angle on the chord, and we see the angle on that is formed up there is 52, so that is 52. And who know how to do the last one?
I think I do.
Go right ahead.
Is it S equals 180 open times n take away 2 divided by I guess 24?
Go ahead, go get him here.
180 times 24 take away 2
180 times 24 take away 2
divided by 24.
divided by 24. Okay, let me show you an easy way, right? And then I'm going to try to use the formula that you're using there, right? The easy way, since we know the sides, we got to find an exterior angle first, and we know that all the exterior angle add up to 360, so it will be 360, and we're going to divide it by the number of sides, which is 24, and what we gonna get there?
15.
15. So this is an exterior angle. One exterior, and now to find the interior angle, it is 180 degrees minus the 15 degrees. And what are we going to get here?
165.
165 degrees. That is the easiest way. The other way that you were trying to find was that in bracket is N minus 2 times 180 divided by n. N is the number of sides the thing has. So the number of sides would be 24 minus 2. We multiply that by 180, and then we divide it by 24. So this is going to be 22 times 180 is how much? And then we divide by 24. Work that out. 22 multiplied by 180 equal divide by 24.
165.
165. So the top part of the formula gives you the total interior angle, the sum of the interior angle. That means the total of all 24 angles for the inside, right? And then when we know the total, we divide by 24 to find the interior. That is one way. But you see how you mix up the formula here? What you did, you would have had to multiply here first and then subtract 2, which would be wrong. It is 24 minus 2 first, then you think you understand what I'm saying?
That's what I meant, yes, sir. The brackets by over 24 and 2.
You gotta. If you write it like this in the exam, how you say it, it'll be a wrong method, okay? And if you write that and you end up with the right answer, they go mark it wrong because you can't follow the wrong method and get it right. You understand that? So whenever you have this, the easiest way, find the exterior angle by dividing 360 by the number of sides and then subtract from 180. Because one interior and one exterior will give you the same thing. I don't need to go through anymore, right? There's one I want to. Look at this diagram here. Do you know how to find A, B, and C? Just this is the last one. This is D, and it says the regular polygon. That means all the angles of the inside are equal. How do we find X? Use that same formula that we just worked out. Here's where you can use that formula. N minus 2 times 180. And then when you get that answer, you see the line go right across, I divide by N. So put that into perspective and work it out.
I got 120.
So X is 120. X is equal to 120. And that's how you get 2 points. So that is 120. They want Y now. What do you think we will do to find Y?
Probably we'd have the two bottoms would be X, so we would just take them away from the sum or the total sum of I'm guessing it's like a trapezium or four-sided polygon. 360.
All right. One point. It only carry 1 point, so you don't need to work yourself so hard. This line here will be the axis of the line of symmetry, because if we fold this over there, we will get 2 equal shape, right?
Yes, sir.
So we know that this angle here is 120. So that means this line divide this 120 into 2, right? So Y would be 120 divided by 2 equals to 60. I don't know if you get it.
Yes, sir.
You get it? Now Z.
Understand.
But somebody said you don't understand?
No, I understand. I understand it.
All right. To find Z now, let me just clear up that. To find Z, we got to look at. Who wants to tell me how we're going to find Z? We can find Z by finding this angle. How can we find that angle?
I'm guessing this is
Don't guess.
the
Don't
two.
guess.
Is it 180 minus 60?
No.
It would be
Okay.
180 minus 90, and you divide that by 2.
Man.
No. All right. What kind of triangle is this? Because it says a regular polygon, that means that side is equal to this side, right? And we know that that angle there is 120, right? So so that little piece would be 120. Sorry, one. Let me read it to you. It'd be 180 minus 120, and when we get that answer, we divide it by 2. So we go
Which
get
would give us 30.
60 divided by 2 equals to 30. So that little piece is 30. You with me?
Oh, so I am down to split.
And so this whole angle here was 120, right? Remember?
Yes, sir.
So if this whole angle is 120, it means that Z would be
Use one of them dirty fellows standing into it.
120 minus that 30, and we will get 90 degrees. That is why you carry 2 points, because you had to find that one first. And always remember, because this was a regular, this could be 120, that could be 120, that could be 120. The whole angle is 120, right? So if we find this piece, which we just found out to be 30, we just take away from the whole 120 to get that little piece over there. Okay?
Yes, sir.
All right. Now geometry time, geometry set time. Now look at this thing. Make a quick rough sketch of this thing. All right, just make a little rough sketch of this, and then I'm going to show you how to do it. Because they say now, you got to, this drawing is not to scale, so you have to make a scale drawing in order to find this length here. Neely, you did this one in class before, right? Neely gone? Neely?
Yes, sir.
You did this in class before?
Yes, sir. We did this in class.
So you can help me explain to the class, right?
Yes, sir.
All right. The drawing of it, the first part is 5 points. Okay? So remember, what is the scale?
1 centimeter to 10 meters.
So your first job is to find out how many centimeters you have to draw. So to change it, we have to divide all of these by 10. And that will tell us how many centimeters we have to do. All right? So LM, if I divide 80 by 10, that will be 8 centimeters, right? This is CM now. That is what we're going to draw on our diagram. What will this one be?
5.5 centimeters.
5.5. What will this one be?
7.8
7.8 centimeter. And this angle, we have to do this angle, and we have to do whatever angle they give us there. So, step 1, you need your maths tool. We will need, first of all, we would need our ruler, and then we will need our protractor. So we don't need our protractor. And I like to use my compasses too. Those are the things that I like to use to do it. So, the first thing we're going to draw is our baseline. Sorry. Did we write it in already? Did we write it in? This was a lot of this. You see, this one is 2012. And this one was 2000. Where was it, man? (2012). And this is a different year one. I don't know what year I have this one. So we need.
That's 2017.
This is 2017. All right. So first of all, we got to get our 8 cm. So here, I get my ruler. I can either use this, put it there, and measure my 8 cm. Right? I can do it like that. I will put a dot where I want to do my starting from. So that I know that is where I'm starting. So I put my point there. Make a mark there. But you can go directly with your ruler. Then you put your point there now. So between that two line would be your 8 centimeter. Or if you don't want to do that, you use your ruler. Let me use my ruler and show how you can do it. And you start from here. Let me use it. Please don't retrace your line when you draw your line. Right? I'm starting from that first line there, and I draw my line up to 8. You see how I did that? I'm going to move out this line here. Let me move out this line. As you go along, you name your line. What is the name of that line?
LM.
And you write in. So you're going to write L M 8 C M. At L, how much degree you going to get? $63?
Yes, sir.
So when you set up your protractor there, which scale will you be using, the inside or the outside?
Inside.
So I go to 60. What up, honey? You all right? And I go to 61, 62, 63 is about there, right? And I right away I can go over on the other side because I know that the other angle should be how much?
90.
So I can put in my 90 degrees there. All right. So what I can do now, I can draw my line from here to there, and you draw lightly. Let me erase it so that I can use a thinner line. From there to 90, I can go beyond, and here I can draw in my 90 degrees. Of course, I can write in my 63 degrees, and I can write my 90 degrees. Who understand so far?
Me. I do.
Can I just start? Can I just go to this dot and draw across it to make my angle?
No, sir.
No. That is where I like to use my compass. What is the length of this piece over here?
55.
So I go to 55. Measure my 55 there. You see that? 50 and 5, 55. And now I take the point and put it there. Then I go as close as possible to that line, and I just make a mark so that I know that is where my number will be. What would be the name of that point?
MN or NM.
Here is N, and so here is 5.5 cm. Oh, on the other side is how much? 7.8 or something like that?
Yeah, sir.
Give me a minute. Hello? Hello? All right. What do I do? Let me see how much I get distracted here. 7.8, right? So I will now take my better 7.8, 7.56. That is my 7.8 there. I got to adjust this one here. And I put it at L. And mark that line up there. Who with me so far?
Me.
So what would be the name of this point here?
P.
P. And all we need to do now is to draw our line to connect those 2 points. You draw lightly, you can either erase those if you want, or you can leave it. That because that don't count anymore. So this is my. Well, how much was this? How much was this?
7.8.
7.8 cm. And so we would have completed this to get our 5 points. Now the last one says use your diagram to find the actual length of PN. Who wants to tell me what do I do there?
Don't you just use the ruler to measure?
We can just use the ruler. We can just use the ruler there. But I really like to use this thing here first. Or you can use the one without the pencil. You set the one that you call the dividers.
The divider.
I put that point there. Because you have your paper, you can turn your paper to suit. So when I do that there, you see what I did there? I just come to on my ruler and see how much that is. So I get an accurate. So what am I seeing on my ruler there? What am I seeing on my ruler? 4.6. So I can now write up here is 4.6 cm, right? And then to find our answer down here, it will be 4.6 multiplied back by the scale by 10, and we will get 46 meters. All those who think they understand that.
I got 4.9.
Whatever you get, that is right. Because, yeah, that whatever you get. Even if you are wrong somewhere along the line, right? If on the exam this was 4.6, but on your diagram is 4.9 and you use 4.9, you will get your full marks here. Okay? But you can only get a full mark if you put your 4.9 multiplied by 10 as the follow through. You have to show working to get follow through points. Everybody clear with that?
Yes, sir.
Yes, sir.
And that is how you make a scale drawing. Now, let me see. I think I have some. This was 2012. This is another one just like that. Same method. Okay? You see, it's the same thing they ask you when it comes like that. Good. I'm not going to waste time on that one there. I want us to do this one here now. This was 2010 and this came from a paper 1. Most time it comes in paper 1. So it says use your protractor, measure and write down the size of angle M. So I get my protractor and I set it up at M. You see this point where the 90 degrees and the 0 degrees reach, that has to go exactly at the point on M. Okay, like that. This line, when you put this line, you mustn't see that line there. So, which scale are we going to use? The inside scale or the outside scale?
Outside.
You're going to use the outside scale. So what now? What are we seeing here? How much degree is that?
90.
Yeah?
111.
111. You can miss a 1 degree above or below. So if you put 110, you will get it right. If you put 112, you will get it right. Okay? You can go plus or minus 1. So the answer for that one there would have been, when we measure it there, it is 111 degrees, and that is how you get 1 point. Now you say use your pencil, ruler, and compasses only. Bisect the line MN. And then the other part says bisect angle L. All those who know how to bisect a line. Okay, you're going to explain to me how we do it. I don't know, I can't remember how to bisect a line. But I know that I have to use a compass. Who wants to talk to me?
I'll talk.
Go right ahead.
We bisecting M at.
Yes.
You put your compass point at M.
Mm-hmm.
You put the compass more than half of the line.
Do you think I have more than half there?
Yes, sir.
Okay. So what do I do when I do that?
Basically, make a circle.
Pardon me? I can open it a little bit more if I want. That's fine. What I do?
Make like a semi-circle.
Yeah. But when I make that right, I gotta make sure it passes more than halfway of the line there, so that when I construct it, they can join. So I have to do that over there, and then I have to come on the other side and do the same thing, right?
Yes, sir.
Right? What's the next step?
Go to point N.
Yeah.
And I can change it. I can change the radius.
No, sir. Keep the same radius.
You didn't tell me that, please do. So I go up there. You see, because I am using this, I have to take my time. I go to N now.
Mm-hmm.
Right? And I don't really need a big line. All I need to mark that so that I can see it. And please don't retrace. I can see the cross here, right? I come on the other side and do the same thing. I don't need a big line. I can see that. All those who understand that.
I understand.
And what do we do next, Mr. Green?
You put a line straight through the two intersecting points.
Okay, I draw a line from there to there. What am I correct there?
You gotta make sure it's through the intersection.
Oh. You gotta be so that's why you put your ruler and make sure you try it out first, and that is correct there, right? So how do we know if we are correct? We can use this to test it out. I'm showing you how to test it out. You put that there.
Or you can use your ruler and measure it.
You can use your ruler because it would fluster me with my ruler, so I can use this. If I put that there, and then I go on the other side, they must be equal there, right? And I think I almost got it right there, right?
Yes, sir.
Good. So that is how we bisect a line. You must open your compass more than halfway. Who with me?
I am.
Okay. The next one, we are bisecting an angle L. So how do we go about doing that now?
Put your compass point at L, and you could do like a small radius.
I put an L there. And anything that is convenient to you, right? And we don't have to go far. We put it there and make sure it marks both of the lines that make that angle.
And you open your compass up a little.
We can open it as much as we want, no, but we don't want to make it too bad looking. Then we put our point on that one that we crossed there. And remember, when we draw this arc, we got to make sure it cross. We don't make it too small, right? And then we put it on the other side there. We gotta remember we gotta be careful not to change the radius and make sure the point is exactly where it crosses that line there. I go close to that line there. And I make my mark there. Good. Is that good enough for you? Then once again, I have to line, let me see. Once again, I have to line up this point and make sure you go through exactly there. Right? If you see your angle like this, you know you're wrong, right?
Yeah, so.
Yeah. We gotta make sure. So when we draw that line, when you look at it, this piece over here must be looking like the piece over here, the same size. And that is how we bisect a side and an angle. Any question?
No, sir.
All right. Let me see if we have any more like that. Well, we did that one. Okay, this is another one. You see what they say? You see what they were telling us here? This is a 5-point question. Use your protractor. Measure and write down the size of angle O. Again, so most times they're going to test you on this here. This time, which numbers are we going to use?
The outside?
Yeah.
Huh?
The inner number.
That's the inside side.
You look and see where the 0 is on the line. You see when we go out on the line here, this angle is opening up like this, so we got to use the inside number. What are we seeing there?
$122.
122. So you will write your you will write your 122 on this line here. 122. and they have the degree sign here for you. Then you say, using the centimeter scale, measure and write down the length of PQ. So you get your ruler now, and they want the centimeter scale, right? So let us get our ruler. We set it up at PQ. And what would be your answer?
That's PO. PQ is the hypotenuse.
That's not hypotenuse. Because that is not a right angle triangle, okay? What we get there?
130.
All those agree. Put your hand up if you agree with me.
What was the measurement?
My bad, 13.
It's 13. Remember, this ruler, some ruler would have 1, 2, 3, that is centimeter. But this particular ruler is counted in millimeters. A millimeter is each of those little space. So 10 millimeters make 1 centimeter. So when you see 130 and they 1 centimeter, you know your paper can hold 130 centimeter, right? So the answer for that one there would be 13 cm. Good? And the last one say, leaving all construction line, use pencil, ruler, and a pair of compasses, bisect angle OPQ. So which angle are we bisecting?
P.
P, the letter in the middle. So I go there. Somebody talk to me except the person who was talk to me all the time. Somebody whose voice I didn't never hear yet. Okay, I'm gonna call on Alyssa.
You pointed, you already have a point at P, then you draw the arc to bisect it.
I draw the arc to bisect it. I draw the arc to cut the 2 lines that make the angle.
Yes, sir.
And now I can open it a little bit more, right?
Yes, sir.
And then where I put it? I put it that part where I marked there, right?
Yes, sir.
And can I draw the line outside here? Can I make the line, draw the line right there?
Yes, sir.
No, ma'am.
No, you go closer.
Right.
I got to come inside the triangle.
Oh.
And you got to be inside the triangle because it's the angle we're bisecting. And then we don't change the radius now. We use that same radius, right?
Yes, sir.
And then we mark it like that. So you see, this line will be somewhere halfway inside there. Oh hell! Let me lock this page. And so now we just use our ruler and pencil, and please don't retrace your line. One stroke
Draw
of
the
the
line.
pen. Pardon me?
I was gonna say, just draw the line.
Yeah, one stroke of your pencil, and you will get that one right there. So we bisect, right?
Yes, sir.
God, any question on that? And don't erase any of them line. Now, before you get into the exam, and before I forget to tell you, make sure you take a screwdriver and tighten your compass, because if you get it slack inside here, it would be of no use to you. You with me? Your compasses has to be tight. This is the same thing that we did. Use your protractor, measure angle O, and write down the size. Let me see if we have anything different. Most of them are the same. You see that?
Yes, sir.
You're gonna measure an angle. You're gonna measure a side, and you see the same thing here. And then this was the one that we did in 2017. Now this one, they ask you to draw a triangle from scratch. So we're going to do this one here. It say, use your ruler and compass only, construct triangle XYZ with XY 6 cm, YZ 6 cm, XY 5 cm, and XZ 4 cm. And when we do that, then we have to answer these other parts. So the first thing to do that, we draw a line, and it doesn't matter how we draw the line. I can draw my line like that, longer than we need. It doesn't matter, right? Or you can do the line like, you can draw the line like that. But most time people like to draw this like this, okay? And so the first line we're gonna draw is 6 cm. So we get our ruler. Let me close this ruler so that I get it back. I get my ruler. How much they want?
6.
6 cm. So I get my I put it on my 6 there. And sometimes people don't know how to measure the rule. They start from the 1. You have to start from the 0, the very first line. And now we can come on here. We can start either at the end or anywhere on the line. It doesn't matter. I put my pencil on my line. I'm going to make that mark there. Then I'm going to flip my let me lock this before I get problem again. Then I put the point on that line that I write there and mark it, make a mark there. So between those two lines, that is the piece I want. So I will name that YZ. And I put the Y here and the Z here, and I put my 6 cm. Who understand that?
Me.
Then the next line I want is X, Y, 5 cm. So again, this time I go there, I measure my 5 cm. Where will I put this point?
At 0.
At Y.
At Y, because it's XY. So this point, the line that we are going to make now, we go up there and we draw a line. So somewhere along that line there would be my X. Right as it stands now, I can't just draw a line and put in X. I have to do the other side, which is 4 cm. Because that, and since that is XZ, I put my point at Z, and then I go there and mark that line. All those understand that. So now, where those two lines cross, that has to be my X. Okay? So I will put X there. And all I do now, what? Who have to tell me?
Do you connect the...
I draw one line from there to there, and a line from there to there. I don't have to erase those lines because once I put Y, the examiner will know that from this point to this point is my 6 cm. I can write in this one, I can write in my 5 cm there, and over here, my 4 cm. Always labeling them as we go along, right? And so now we would have done the construction for 3 points. What is the next thing they ask us to do? Measure and write down the size of angle XYZ. So which angle are we measuring?
Y.
Y. What is our measurement there?
$40.
40 degrees. Or if you put 41, you can still get it right. You can be up by 1 or down by 1. So 40 degrees. And the next one is the measure, write down the length of the line MN. And you see this is cm, so you got to measure it in cm. MN. That is this line that they give us here. What is that? What is the length of that line?
$9.2.
9.2. So we'll write 9.2 and they have cm there. And I think that will conclude today. Did you learn something today, class?
Yes, sir.
Yes, sir.
Yes.
All right. So what?
Yes, I sure did. Thank you.
All right. What I want everybody to do, right? Go on Students Share. Go to BGCSE Maths and download a paper that they have there that is closest to 2023. And because I have all the paper, I can choose anyone. So I want everybody to get the whole paper too, and we're going to work it in class next week, Saturday.